showing you nice slides like this. And, you know, so NoSQL, you have your key value stores, your graph databases, your column databases, which are not like old school column databases, because that's not cool. Then you have document stores, right? And this still happens today. I just pulled this from MongoDB's website this morning, and it says SQL databases were developed in the 1970s, right? Who cares about that? That's old school. NoSQL developed in the 2000s, and who's going to run their stuff on things from the 70s, right? So if you look at these cool key value stores, you'll see this one at the top. It's called Berkeley DB. You know, I got to thinking about this a few years ago, and is this the same Berkeley DB that was sold as Sleeping Cat back in 2006? Or the same Berkeley DB included in 4.4 BSD in 1991? Or the same Berkeley DB designed to replace DBM that came with AT&T Unix in 1979? Now wait a minute. DBM didn't have SQL? Was a key value database? You know, what if DBM was one of the original NoSQL key value stores in 1979? And if that's the case, I used NoSQL before it was cool, as did many of you, I'm sure. But when you're at these conferences, these NoSQL conferences, you point out these things, and especially, they're kind of like a religion. People get a little bent out of shape about it. But eventually, businesses, you know, the developers kind of started this NoSQL movement, and businesses started using these systems that the developers were writing, and they realized that, you know, SQL actually did have some advantages. You know, there's some pros and cons to SQL and NoSQL. So, especially in reporting, right? Unless you're using like Hadoop, running reports against MongoDB is not so easy. So that's when that radical community kind of changed to being like, well, we don't actually mean no SQL, we meant not only SQL, right? So, of those, you have Hadoop in the big data space, and then you have kind of Mongo, which is the big, you know, biggest NoSQL database out there. So what is Mongo? How many people here use Mongo? All right. So Mongo's a document store, and if you think about documents, right? Documents are these babies, right? JSON. Because XML documents are old, nobody uses XML anymore. JSON is the new hotness. So why use Mongo? Well, it's schemaless, right? Because schemas are not cool. MongoDB is highly available, and by highly available, I mean you need to have enough of them running to make sure that when one fails, it still works. And it is fast, and we won't say why it gets fast, but most importantly, it's because Mongo's cool, right? So all of this sounds good so far. So why not use it? Well, for my Mongo people here, how many times have you had it crash? Yeah. If it hasn't, you're not using it strongly enough. And there was this funny video put out against MySQL and Mongo a long time ago, and I'll say it is over the top and, you know, not safe for work, but I would say view it, it's fun. So, DevNull is web scale. Why not use it? Well, it does have some odd transaction semantics as well in terms of collections. And in most cases, when you ask an Oracle DBA, because the developers want to bring this in, and they ask their DBAs, because they're like, oh, it's a database, can you manage this? You generally get something like this. So that's why I want to talk to you about Mongrel.io. Oh, and the mongrel in the corner, that's how you feel after managing Mongo for too long. What is it? It's a MongoDB compatible system that runs on top of a mature relational database. So think of it as Mongo plus relational. So what is it? It's cool, right? It's hip, and I might have just made it not cool by calling it hip. But it even has I on the name, so you know it has to be good. So it's open source, it's written in C, and let's face it, C's badass, okay? There's no built-in garbage collection up in here. So it's compatible with MongoDB, so it's kind of the best of both worlds, right? How does it work? Well, it maps documents to tables. Yes, I know, it does have to do joins, I'm sorry. That's not NoSQL, but to the user it looks like it. And schema is implicit, so you say Mongo schema list, right? Well, when you look at a document, right, you have all this data and attributes and values, and nowadays they call that metadata, right? Because metadata is a much cooler name than schema. But if I look at a document, I kind of say, well, yeah, there's a lot of primitives here, and for the complex types, those are usually tables that you would put into a join. So what we do is we actually map a document into underlying structures, and each of those object structures are unique. So if you have multiple collections or a collection that has multiple types of the same object, we'll actually merge it into one type of structure, which is good for columnar storage because you'll get better compression. And what it does is it actually speaks the MongoDB wire level protocol. So any application written against Mongo works without a problem. So since I do have to do joins, right, what do the benchmarks say? Well, yeah, I'm not supposed to benchmark it, but I'll talk a little bit about it here. So if I want to take a MongoDB database and I want to actually run it on Oracle, then how big is it storage-wise? Well, anybody that's used Mongo knows it's very inefficient in storage. So, and most MongoDB databases are pretty small, but if you look at a couple gig database in Mongo, in Oracle that's only half a gig or under half a gig because Oracle storage is much better than MongoDB. And if you look at how fast, well, Oracle's never going to be as fast as Mongo. Mongo does a lot of trade-offs to get its speed, but most people using an application don't actually notice. But what if that's not fast enough? Well, because it allows you to use pretty much any backend relational database, you could switch the backend to times 10. Or if you don't want to use commercial products, you could use MySQL. Or if you want high availability and blah, 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 you can use MySQL cluster. And we're at an Oracle conference, but if you don't want to use Oracle at all, you can use Postgres or another commercial database. So why did I build this? I actually built this when I was at an Oracle conference a year ago. And people were talking about MongoDB, people bringing it in, it being hard to manage, not knowing what to do with it, some of the issues that they were having with it. And so I said, hey, all these companies already have Oracle or MySQL installed. Let's just give the developers kind of what they want by giving them that Mongo functionality, but letting the DBAs still have that solid relational database there. So I will be posting the code for this shortly, but if you want a copy before I do, just let me know and I'll get you one. Thanks.
God knows how many have come in the past few minutes.
Are you going to publish the presentation?
Sorry?
Are you going to publish the presentation? I need to show it to my manager.
Sure. Yeah.
Yeah, I need to put my name on it. Yeah. What the hell is this? VGA? Right. Sometimes it just works. Or not. Okay, 10 minutes, right? Okay. It's going to take me that long to say the title of this. OpenZFS Adaptive Endianness and Cross-Platform Migrations. Done. Any questions? Okay, what the hell am I doing talking about Endian stuff? We're supposed to be talking cloud, right? It's even overcast outside. Fact is that in order to get to the cloud, if you're currently running proprietary Unix, unless you're proposing to go to the cloud on that vendor's cloud platform, and of course that's the big thing this week, unless you're prepared to go to the cloud on that vendor's platform, you're probably going to have to convert to Linux or Windows, one or the other. Those are the platforms that most cloud vendors support only. So, since we're going to have to cross-platform, you know, we're going to have to make some changes. So, the thing is that most of the proprietary Unixes are big endian. The Linuxes, like other Intel platforms, are all little endian. There's going to have to be a cross-platform migration that occurs. My first experience with Endianness was back when I was young. In the 80s or so, I was trading tapes across the pond with some folks over in that place called the UK. And among the records that I was transferring back and forth on tape were some bit masks, you know, because why should we take up space with entire bytes? Why don't we just, you know, flip a bit and everything like that? And there was a serious miscommunication that was going on. I couldn't find the right bits that were being flipped and everything. And after some discussion with my counterpart across the pond, we discovered that I was counting from 8765433, you know, or 7654310. He was counting 0, 1, 2, 3, 4, 5, 6, 7. And you know, we were just reversed. And no big deal. I chalked it up to cultural differences. Like, he drove on the wrong side of the road, I drove on the wrong side of his road. He said tomato, I said tomato, he said tomato, the whole thing. I didn't realize that what I was seeing was my first experience of Endianness. It's not cultural, it's part of the chip, right? So some chips are built with the bytes going this way, other chips are built with the bytes going that way. That's the big difference that has to go on here. When was that decision made? I think it was made back in the 60s or 70s. So we've got two societies separated by the same language. No, it had nothing to do with society. I could have found that very same problem, you know, with the computer down the street, so to speak. So it's not that interesting, but it's Endianness. Where did the term Endian come from? It had to do with Gulliver's Travels. You know, don't know if you all know this little bit of background, but they decided to use the term over a short vignette or conflict that occurred in the novel Gulliver's Travels, where in Lilliput, Gulliver was big, the Lilliputians were tiny little guys. There was a religious sect that ate their soft-boiled eggs by cracking only the little end of the egg, and it, from Unix to Linux. Has nothing to do with the religion of whether HPUX is better than Solaris, or whether Solaris is better than AIX, or AIX, or all three of those are better than Linux. Has nothing to do with it whatsoever. It has to do with hosting. A lot of the hosters, you know, are just using Linux and Windows and get over it. That's the end of it. It's not about technical merit. It's never about technical merit. Otherwise, we'd still be on faxes. I don't even want to start that discussion. So, yesterday on the Oracle L list, how many folks are on the Oracle L list? I fully expected that. Mostly it's only my hand being raised when I ask that question, but here we've got at least a third to a half of us on the Oracle L list. I don't know what that says about us, but one thing I know that it says is that we're up to date on all the arcane technical stuff that nobody else wants to know. So the question was asked, how would I convert a 100 terabyte 11204 database, you know, from AIX to Linux? No reason to go into why, it just has to happen. So what are the alternatives? Export, import, obviously. You know, there's various ways to do export, import. Replication using Golden Gate, you know, logical replication. It's going to, you know, extract from one side and apply with SQL on the other. SharePlex would do that. And then there's the RMAN convert data file method. Okay, basically using RMAN as the swap bytes, swap converter. So the steps for RMAN convert data file are, you want to do a validation ahead of time, because the technique of using RMAN convert data file, first of all, there's two commands with RMAN convert. There's RMAN convert database, and then RMAN convert tablespace data file. The RMAN convert database is way too optimistic because you have to be on the same Endian platform, converting from, say, AIX to Solaris or something like that. But whenever you're going from any proprietary Unix to Linux, you're converting from big to little. So you have to use the other two methods, convert tablespace and convert data file. So there's two steps here. First validation, to see whether you're going to violate any of the many restrictions that are involved in this kind of conversion. You use an RMAN, and also using transportable table space, because that's part of it. And what you need for that is a Unix database and read-only. So that's not going to be production. The production database that you're going to convert, when are you going to have a chance to switch it to read-only in order to run this stored procedure in DBMS TDB? It will actually fail if you don't have the database in read-only. So there's no way to run it without it. So you have to make a copy. And then when you're finally ready to actually pull the trigger on a conversion, you again have to have a read-only source copy. Why read-only? Well, we're using TTS for this technique, transportable table space. We can't have an open read-write database for running with TTS. So first step is to copy the Unix database, open read-only. Is that thing blinking? Okay. I'll ignore it. Copy the Unix database, open it read-only. Do a metadata export-import, just like you always have to do with TTS. Create a stub database on the Linux side. Use TTS and RMAN convert data file to actually do the copies of the table spaces and data files. And then finally, there's some finishing steps, basically do the recompile a PL/SQL and stuff. Pretty straightforward. But we're talking about 100 terabytes here, okay? So just to do the validation, we have to copy 100 terabytes just to run a store procedure that's going to finish in less than 30 seconds. Ouch. Conversion also, we have to have a copy of the Unix database, and we have to open it read-only. Have to recopy that 100 terabytes, because by the time we finish with all the validation steps, we might want to have a fresh copy to start with. Then we have to do the export-import of database metadata, for TTS. Create the stub. Do the RMAN convert, copying 100 terabytes over to Linux now. Yet another copy. So now we've invested 200 terabytes in this process. And then finally the finishing steps, relatively minor at this point. Oh, if that 100 terabyte database is something like PeopleSoft, it's got about 1.5, 2 million data items in the data dictionary. That is the long pole in the tent, is doing that export-import. It's not complex, but it takes a hell of a long time to do single-threaded. That's something that we can't really do much about. That's a PeopleSoft thing. So, ZFS. We have this thing in ZFS called adaptive Endianness. Basically, ZFS blocks are broken up into a metadata header and a data body. Anyway, so the metadata, one of the things it contains is the platform that wrote the block, and inferred by that is the Endianness. ZFS also has some deduplication, so that when you write a block, it's not going to store an additional data body if it doesn't have to. It might just store just the header, just the metadata. So if you take these two things together and combine them, we can write a ZFS block. If it doesn't differ by anything more than Endianness, we don't have to store that additional same block. Cool for cross-platform migration, because what it ends up meaning is that with our steps for RMAN convert data file, for the validation, this has nothing to do with the ZFS Endianness stuff, but when we want to create that read-only source database, we can just create a virtual database. And of course, I'm plugging Delphix. We can create a virtual database, run our validation routine against that virtual database. So we're not actually provisioning 100 terabytes, taking up 100 terabytes of storage. We're provisioning a virtual image, if you will, of that database, setting it to read-only, running DBMS TDB and DBMS TTS procedures against it. Boom, we're done. Doesn't take up any storage. Then for the conversion itself, our source database is, yet again, just a virtual database. When we actually run the conversion to copy with RMAN from that virtual database, and then write back down to the same storage, which is on the Delphix appliance, in Linux, it's going to detect which blocks changed other than the Endianness conversion, and it's going to deduplicate. So in the end, the exercise that we have presented before us in Oracle L is going to result in 10 terabytes of read-write during that phase. We can do that in parallel. But the end result will be a database on Linux that only takes up, in its own right, just about 12 gigabytes. Mere fraction of 10 terabytes. So just wanted to bring that out. Without data virtualization, you need a whole lot of storage. Bring it on. With this feature, this combination of ZFS features, you've got the ability to do the validation very easily, very quickly, and even though it still takes a fair amount of time to copy 100 terabytes using RMAN, at least you don't have to allocate 200 terabytes for it. And that's all I've got. So thank you very much. I thought it was cool. Somebody's coffee is down here. Somebody.
Hey, it won't be for long, I'll just kick it over.
Yeah, not jittery enough.
Well, yesterday's presentation, of course, was where I tried to scare the hell out of everybody. Today, I'm going to leave you feeling warm and fuzzy. I hope. Oh, except for the last little bit at the end.
It's always the last little bit at the end.
Yeah, well, sometimes I work up to it, and sometimes it just springs on you. Okay. I will also run up my clock, so I remember to stop in time. Yeah, that makes sense. Okay. So it's virtual columns today. We had column groups yesterday, and the threats and so forth, and the benefits, and really the threat of indexes. Today we've got virtual columns, because virtual columns are really quite great. There's the usual sort of introduction of who I am, but you probably know that. I was very upset earlier on today when Maria Colgan explained to the audience that I came into sites and created lots of indexes to make their systems go faster. Right? No, I get paid, well I don't always get paid for this, but when I go in I try to get rid of indexes without having to pay a massive license fee for in-memory. So virtual columns can do very clever things for you. Let's start with sort of lightweight trivial stuff. Why do we want virtual columns? Well, bad cardinality estimates tends to lead to bad execution plans. Bad execution plans, what causes bad cardinality estimates? All sorts of things, but things like functions of columns cause the optimizer just to go wild with guesses. There's a few hard-coded numbers that Oracle throws in because it says, I haven't got a clue, oh, let's call it 5%, right? So if you've got virtual columns, which represent those function-based columns, you get better statistics, provided you remember to collect the statistics, of course, and sometimes people overlook that particular point. And of course, one of the nice things about virtual columns that are on the side is that they may be completely invisible to the application. You don't have to change the application to take advantage of them. And when it comes to invisibility, in Oracle 12c, you could even say, create a virtual column, it really is invisible, so you don't have to worry about application code, which does a select star from table. Invisible columns doesn't get caught in select star. Things which just say insert into table values without a list of columns to insert into, you don't get a problem. Whereas in Oracle 11, if you create a virtual column, you may find your application crashing or producing very strangely formatted outputs because star has included that virtual column. So we can do things which are enormously helpful and perhaps not visible to the application. Now, quick demonstration type time. This is just one of my standard sort of programs, scripts for creating some data. A million rows down here. Really, of all this lot up here, for today's little chat, I'm only going to look at two columns. This mod 10,000, which means there's 100 rows for each distinct value, and this trunk of sysdate plus a random integer between 0 and 999. So there's 1,000 distinct values for the dates there. Okay? Well, having created that table, gathered loads of stats on that table, we do something like this. Select where sign of mod 10,000 equals 1. Quick working. Sign is equal to 1 if the number is positive, minus 1 if the number is negative, and it's 0 if 0. Well, we have got 1,000 rows in our table there where mod 10,000 is 0, so there are 999,000 rows where mod 10,000, the sign of mod 10,000 is 1. The optimizer's estimate, 10,000 rows. It's quite a long way off, 90 out by a factor of 99. Okay, bad luck. Why is that? Because function of column equals constant. Oracle says, who knows? I've got no idea here. Even though it's an internal function, I know exactly how it works. I've got no idea what I've actually done with it. So it uses 1%. How about this one? A variation on the theme. We'll go to trunk of date 1000 is not equal to a specific date. Well, we know that everything, there are 1,000 rows per date for 1,000 dates. There is one date, one set of data, 1,000 rows in the table where the date is the 1st of December 2015. The rest of the data there, 990,000 rows, is it? It's 999,000 rows. The answer is not 2015 Dec 01. Optimizer reckons the answer to this one is 50,000 rows. Function of column not equal to constant, 5%. That's kind of funny really, because if I had said trunk of date equals 2015 1201, Oracle would have said 1% of it's the 1st of December, 5% of it's not the 1st of December, 94% of your data just disappeared. There's a certain inconsistency there. So we have a slight problem. Let's chase up this problem here. What do we do about this? We create a virtual column. Here we go. Alter table, add a trunk date column. It's generated always as trunk of date 1000, virtual, and in 12c I could add in invisible as well. So what happens once we've got that virtual column, and remember to collect stats on that virtual column, and typically I just jog people's memory, very rarely do you actually want to do anything other than collect stats without histograms. Select, I haven't changed the code, right? I have not referenced the virtual column. What does our plan now tell us? Our plan tells us it's 990,000 rows, 999,000 rows. It's right. Interesting little detail, the filter predicate down here references the virtual column, not the original expression. Odd little things like this appear when you start playing with virtual columns. It's got it right. It's been a terrific help. Okay, that's jolly nice, because we've got better stats, we'll have a better chance of getting a good execution plan. Let's consider an alternative example. I've just got a table here, not worried too much about how much data we've got in it. I've got a dates time column here, which I happen to have highlighted there is declared not null. Okay? I've created an index on that date column. Unfortunately, the people who wrote this application weren't thinking terribly carefully when they were thinking about what do I need to do with my data, and there's this very popular query which says, get me the data where the trunk of date time is greater than or equal to trunk of sysdate minus 1. Get me the most recent data, and I've truncated. We can't change the code, unfortunately. What do? We've got to muck about somehow. Well, it's to start with just the same problem. We're going to get a bad cardinality estimate here. Oracle's going to use the 5% guess here with the greater than, rather than the 1% for equals. Okay? So step number 1, we add in the virtual column, we gather stats on the virtual column, and sure enough, we did have bad stats, bad estimates. Oracle can come in and say, that's okay, I've now got here something which says it's the 1,440 rows, which is a day's worth of data. You'll have to take my word for it, that's the correct thing. I had data which was 1 row per minute. Okay, so that helps us. But we want to get at this data efficiently. Do we have to create an index? Who thinks we have to create an index? Who's been to my presentations before and knows that there's always a catch question? Oh, only a few people. So the rest of you are just being very cautious. Okay, that's sensible, fine. We do not need to create an index. What do you know about what happens when you compare trunk of date with the date itself? What can you tell me about trunk of date compared to the date itself? Sorry? No, that's telling you about indexes. Okay. Compare a date with the trunk of the date. What can you tell me is bound to be true about that comparison? Greater than or equal to. If you truncate the date, it's got to be less than or equal to the date you started with. Yes? Always true. Inevitable. Right? So let's tell that to the database. Add constraints. Check that the date time is greater than or equal to the date only. It's extremely obvious to us. Technically, it ought to be extremely obvious to Oracle without being told as a constraint. This is just a truism which we have turned into a constraint on the database. What's the impact of putting that constraint on the database? Oracle says, hey, you know what? I could use the index. Isn't that amazing? Yeah?
Yeah.
Thank you, Tim. Right answer. That wasn't a catch question. Okay. Notice here how Oracle deals with this. It says, first of all, access. I will go for the date time is greater than or equal to -1, and then I will filter this bit. It's sort of turned the constraint into an extra predicate that helps it work out how to get at the data as efficiently as possible. There is a little oddity, because our index range scan, Oracle predicts 10 rows, 10 row IDs fetched, and then says, with those 10 row IDs, I will find 1,440 rows in the table. So it's not 100% perfect, right? But importantly, it has got the right number of rows from the table as its estimate. Fantastic. So virtual columns, absolutely great. Right? If you can be just a little clever with them sometimes. Now remember I highlighted the fact that that date column is declared as not null. This trick, this strategy, will only work if the underlying column is literally declared in the table definition as not null. You can't add a not null constraint, that doesn't work. You've actually got to have the column definition not null. Okay? So there is a limitation on when you can use this. But it's there. It's amazing what you can do. And since I never like people to go away feeling warm and comfortable and happy, I will throw out one little warning about function-based indexes. It's terribly easy to get caught 12 hours after you've been clever, right? If you're on 11G or above, we tend to use the approximate NDV mechanism for gathering stats and the auto sample size. This gives you a 100% sample, but works out things like the number of distinct values using the approximate method, which tends to be accurate within about 1.5%. It's very quick, just by a table scan of the whole data set without having to do any massive sort aggregate. So that's great, okay? Until you create the wrong function-based index, which has to run, the wrong virtual column, which has to run a function on every single row in the table. So, for example, I did on one occasion create a column, which was a virtual column, which was get the length of a log. And suddenly my gather stats went from really quick to really remarkably slow, as Oracle said, I've got to go and get the log. It shouldn't have needed to, because the information is in the locator. I've got to go and get the log to find out what its length is, and do that for every single row in the table. And quite recently, I forget whether it was OTN or Oracle L, the list server, which Tim mentioned just a moment ago, someone had the virtual column which actually said, I want to find if there's a certain character string inside this XML object, which has been stored, of course, as a clog or possibly as an XML data thing in the database. So they created this flag column as a virtual column, and this was totally catastrophic. I think they said the time to gather stats has gone up from 3 minutes to 3 hours, because that decode of in-string of XML examination was applied on every single column. So virtual columns are absolutely fantastic, but remember, the function has to be executed for every row. And you might not notice the cost of executing the function occasionally, but for a large table, every row, you can cripple yourself on the gather stats call. This last one, by the way, I think that URL is the little story about that particular example. So virtual columns, great. Remember, you can do more with them than appears to be possible at first sight. Right? If you can tell Oracle the truth in some way about an interesting relationship between the column you've created and the column you've created it on, right? Maybe you can use an index which doesn't exist, or make one index look like another index. And you can go around and tell Maria, Jonathan says you don't need to add indexes to make your system go faster. Thank you. And my clock was no use because the screensaver kicked in after 2 minutes.
Also, everybody, there's lunch outside. You're not supposed to bring it in here. We do. I think the audio is piped into the foyer, so you can eat your sandwich and listen to the presentation too.
That's a bad idea.
Nah. Stay here. Well, you have sandwiches at the parade. 10 minutes from now. Yes, they'll be here in 10 minutes.
Tape let loose a little bit.
It's all good.
Oh, it tipped sideways. I straightened it out for you.
Oh, perfect. Thank you.
Or at least you might want to add some more tape or something
Hey.
because it.
You recognize the checkbook? Okay. Ah, that's cool. That's nice. That's fine. Yeah, I'm here about promoting understanding, and yeah, it's. I don't know if you read the news regarding Volkswagen. At least in Germany, it was all over the news. Maybe you recognize a bit of it. In case if you don't notice, I am German. So yeah, maybe it's interesting to see my perspective. Just a disclaimer, please don't take me serious. That would be bad for my reputation. Yeah, Germany and US. Germany was a country of kings and became democracy on behalf of Americans. And America became a democracy on behalf of many Germans going over to the new country and helping to build it, among others like Irishmen, Englishmen, whoever. And yeah, it's always convincing to point out the difference, but it's easy to find the things we have in common. And I'm very proud that Germany and the US can be friends now without throwing things upon each other. Sometimes we aren't, but sometimes we are, and this is what counts. Volkswagen and Oracle, big companies. Volkswagen was founded during World War II, making cars for the Nazi people, for the small people in Nazi Germany. It didn't work for long because sometimes eventually they started out running out of resources. But Volkswagen is still there. And Oracle started making databases for the Central Intelligence Agency for spying on the Russians and for keeping track of American communists. And yeah, there was an evolution, and both companies are still there. And maybe Volkswagen can be something to allow a perspective on how Oracle may look like in 40 years, because Volkswagen is roughly 40 years older than Oracle is, and so you can see it. A big difference is Volkswagen still is partly owned by the government or by the state. Oracle always was a privately owned company. Yeah, and Oracle Open World over there is a very cloudy business sometimes. And so this talk also is about the cloud. The Volkswagen cloud looks a little bit different. No, it's white. So I guess this is not really, maybe the worst stuff you can see, the worst stuff coming off an exhaust is what you can see, actually. Yeah, the Oracle Cloud is something we all appreciate and we want to have desperately to save jobs in DBA business. And yeah, but maybe there are disadvantages on both sides. For Volkswagen, it was risky. So I'm not sure what happens to the responsible people at Volkswagen, because what they did was fraud, nothing else. Oracle hopes to become Scrooge McDuck, I guess it's the name in America, the Disney, the rich duck in the Disney world. Yeah, hopefully they can manage that. Transportation is also different. In this case, on the left, you see a Volkswagen bus. It's a small one, a minivan, quite old one. It's Volkswagen outside and Volkswagen inside. On the right hand side, you can see a bus. Outside is Oracle, within there's something different. Volkswagen does quite similar stuff. One of the biggest companies in the world making working robots is Volkswagen for automation of their car plants. And they have robots labeled with the Volkswagen logo, and there's Oracle software within. So no big difference. Licensing is always an issue, and you have Standard Edition 1, and Enterprise Edition in Volkswagen as well. Above it's an Audi. Audi is the premium sector of Volkswagen Corporation, and Enterprise Edition is always growing, and the best features are only available in Enterprise Edition. The Standard Edition is the Volkswagen brand itself. You see a Passat here. Yeah, it's available up to 8 cylinders, and you can have all you need, but the last 10% isn't available. And yeah, but you don't have to pay extra for a display of your speed. In Enterprise Edition, you might have to do it. Standard Edition 1, that's a Skoda, in case if you don't recognize it. And no, the red X is only on the Oracle side, so Standard Edition 1 isn't available in Oracle anymore. But Volkswagen will not start remaking my Skoda into a Volkswagen when I have the next maintenance. And yeah, another thing is about fraud. On the left you can see NOx emissions. And I don't know if you have seen Kerry Osborne's presentation yesterday regarding the SQL translator. Yeah, I don't know if you see the things they have in common. I don't say Oracle is fraudy in this case, but maybe a user is. I don't know if did you recognize how how Volkswagen managed to do this fraud? The system, the control unit in the motor in the engine was made to recognize if you are actually driving, and if you had high wheel spin and low engine load and the vehicle not moving, they switched to a special code path and said, okay, let's burn more fuel, be less efficient, but have better exhaust figures and numbers, especially for NOx. NOx is a combination of nitrogen and oxygen, and there can be various combinations of that, and it's bad especially for the environment and for the health of the lung. The problem is if your engine runs NOx, low on NOx, it consumes more fuel. And when the car runs on the street, they are reducing the fuel footprint and raising the NOx footprint. This is the trouble. And this problem is widely known. The truck manufacturers all over the world are doing this for 10 years. But one day, a smart guy said, Volkswagen has a lot of money, let's take it. No, it's sarcasm. Doing that is fraud. But you know that every tool in the world can be used for fraud and can be used for the good. And the best example is the SQL translator. You don't know if you can read that, but if you do select 2 from dual and you get back 22, you may freak out. And the same was the car tester who checked the car. Said, ooh, I expected something entirely different. And the cause of this car fraud detection was that the governments all over the world are monitoring air pollution. And they are also checking how much exhaust stuff the cars are spitting out. And on the paper, the exhaust figures from the cars are going down and down and down, and in the real air pollution kept constant. And they said there has to be a difference. And if you see in Oracle a difference, sometimes it's worth looking if somebody is doing fraudy business. What I want to say, IT people, we have power. Use it wisely, because people start depending on us. No, they depend on us. And there's an old sentence, refreshed by a modern movie. Take your responsibility. They rely on our data. Thank you very much.
So again, we have lunch in the foyer behind us. Please don't bring food in here. Please eat it out there. Ideally, I think the audio is piped out there, so if you're still out there while the next session starts, you can hear it. And in a half hour, at 1:30, we have hands-on labs at the room at the other end of the building called the Creativity Room. So we'll be having Toad installs, DB Visit, and Delphix on your laptop. People there to handhold you.
Still writing slides? Here I am. sure hope it's good. He doesn't put he puts on a bathroom. He gets his coffee, walks into his office, and turns his machine on.
And that's not working. It's great. And then at 12, my wife, we have lunch with the three of us. And then really the event is still
That goes Thursday.
That's great. So then when he comes home after in the afternoon, instead of my father was a Mason, he still is his father Mason, and he just every day, really every day, he got to work at 5:30. And he slept. Then we came in and slept again. And then all he did. And now really getting. Well, the other thing is getting out of bed. No. Really, until 8:45. Get
Oh
up.
my God, that late, really? Nice.
Yeah, yeah.
Are you more of a evening
My-
person or?
I'm an evening person, and the people who are managing are in Dallas. So at 3 p.m. I start getting my email. The emails coming in start rising because
Yes.
then Dallas awakes.
Yeah. So that's what.
Well, having a family also means that we do things at really fixed time. So we always have dinner at 6.
Yeah, right.
And well, everybody's talking about stress and maybe force things with me. Thank God. It always is. They always understand it and going for the dinner. I'll get an hour.
big one happened at, of course, 1 or 2, whenever it was, when I decided, I'm going to do something different. Time. Let me go tell everybody. I'll be right back. The Child Predatorium, I'm Kier. You've seen a lot of really good things in the room this week, or yesterday and today. This one will be completely different. I rehearsed that line on the way here, by the way. That's, Google spreadsheet together that was the schedule, and he invited a bunch of us to put our name wherever we could find a free space. I wrote, Kerry Millsap Performance. And then a few weeks later, one of my colleagues at Accenture asked me, because I wanted to put it on some website, well, what is your abstract? And I said, it is Kerry Millsap will talk about performance. And she said, got it. Got it. So that's what I intended to do. So if you'd asked me yesterday, in fact, some people did ask me yesterday at about 10 p.m. or so, what are you going to talk about tomorrow? Completely new, and it's going to be fun. But that's what this venue's for. This is like the lab where you get to watch people with the test tubes. This is not the fancy, polishy stuff that you know, all the politically correct stuff and everything. Having said that, I'll show you the thing. This just says how old I am. That's since 1985, and this is how many people have reported to me at various phases of my career. And you can see I'm a relatively happy little solo guy right now. Yeah. Yeah. One time somebody asked me, a college student asked, why'd you slant it like that? And I said, so it'll fit. Actually, when they asked me that, it was slanted this way, and then it became it became obvious to me that yeah, maybe it should go the other way. Yeah, it's harder to make it bend, so it's not. Okay, so that's me. Hi, I'm Kerry. Nobody laughed.
Hi, Kerry.
Thank you. Thank you very much. I've not been in Keynote since 4 this morning until now, so I'm back off the wagon. All right, this is the free thing that I want you all to be aware of. If you've seen or heard of me talk about this book called The Method Art Guide to Mastering Oracle Trace Data, it's available for free. Just go to methodart.com and click on the thing that says free book. And then when you do that, there's this hugely intimidating form that asks you, where can I send your free book? And then I'll send you your free book whenever I get back to the hotel room. Now, I want to start with something that I really debated seriously whether I would say or not, but I have to. There's something I need to say about performance data. And it's this. The surrogate measures thing, it just kills me. Surrogate measures suck. And you never say the S word over at the other venue. You would say something like, derived measures suck. But by that I mean utilizations, latencies, samples, hit ratios. These things drive me nuts, and the reason is they're too hard, they're too error prone, and too slow. And it reminds me very much of when I was younger, and somebody would take me out to look at the night sky, and they would say, you see the stars in Orion, and you see the shape, you see the club and the belt and the sword, and I didn't see any of that. And who's to say I couldn't see this, right? There's absolutely nothing in the sky that deterministically defines that I have to see this thing that somebody saw 2,200 years ago or whatever. And I guess it's safe in a group of scientists to sort of mock astrology as sort of the, quite obviously one of the most easiest targets for, bullshit pseudoscience that you can think of. But this is how I feel every time, B-stat, E-stat, sit in a room and go, oh, I see the sword. No, I see the ears. And, no, I see. It's too much for me. And this is probably unfair to say, but it's truthful. I feel like the state of that hasn't advanced that much with the evolution of B-stat, E-stat into StatsPack and even AWR. And I think that's incredibly politically unpopular for me to say that. But my thing about why I don't like even AWR is this. The code path for measuring software belongs to your tools, not your brain. And it's sort of my relationship with software that makes me have to go do a project to figure out why does this thing not make sense even to look at? to have to go do a mini project to figure out how do I make sense of even looking at this. It sort of drives the code path in my brain that is the I am offended code path. It makes me feel like this is a problem that we can code ourselves out of. So some specific things that I mean that I'll highlight for you. I've just got a very short list here that was written at 3 a.m. God, I hope it's good. Called Some Requirements for Measurement Tools. So number one is relevance. That's 42 seconds, and they wish it were 4.2 seconds instead. The tool that you're looking at should say, here's where your 42 seconds are. And it shouldn't take you a lot of mental code path to get from what the tool shows you to get to the, okay, here's my 42 seconds. So relevance to me is the number one most important attribute in this space, as it is in most spaces. Number two is determinism. The process of interpreting what you're seeing needs to be repeatable and teachable and not require intuition or experience or magic. So determinism is really important. Determinism is I can send the output of this tool to somebody in Uruguay and I can send it to somebody in Tampa, Florida, and without corresponding with each other, they can figure out and get to the same conclusion about what am I looking at here. So no mystical jumps of, magic happens and then suddenly some understanding occurs. The third thing I call integrity. And that is things like the numbers in a column that has a sum at the bottom. The numbers need to add to the sum at the bottom. For God's sake. And another thing, I guess it's on the next bullet, but this thing where some of the numbers look really small, but then you realize, oh, there's an M after that number, so that's an M. Oh my God, how wide should I imagine that number to be? Well, God damn it, there's code path that's in your head that should have been in the tool. I get very worked up about these things. The last thing I want to mention, the last requirement for measurement tools needs to be quality. There needs to be no unit mixing. That's the thing I was talking about a second ago. No chart junk. No like, oh, there's a line. Why is there a line? If the pixels in the line don't contribute to your understanding of what you're looking at, then the line shouldn't be there. And I'm channeling Edward Tufte when I say that. The word chart junk is an Edward Tufte word. No long jumps. Anybody ever write C code? Remember the set jump, long jump thing? Set jump is where you say, somebody might someday want to go to here. And then 26 modules away, there's a call to a long jump that can go to there. And it's useful. You need these things in parsers where you need to be able to pop through an arbitrary number of function calls in the stack to get to an error message or something. But it's even though it's a tool we need sometimes, it's not a tool we need in our diagnostic tools, where you're looking at something going, why does 42 and 17 somehow magically equal 98? And then you realize the only way you can figure it out is if you long jump to some other report or some other tool or some other $V thing someplace to try to get a description of why that's the way it is. So that's what I mean by long jump. As an example, and this is my stuff, but just as an example of how it can work, is at the top is a list. It's a table that lists experiences that people had in the system. It happens to be data generated from a connection pooled trace file. And inside that trace file, since the system is using connection pooling, is a list of different experiences. So this 19537 thing is actually a line number in the trace file. This is what this report generates. And a person has experienced it took 2.212251 seconds. And I may want to know, well, why? Why did this stuff starting at line 19537 take 2.21222 whatever seconds? And I should be able to drill into that and have that number show up in the bottom line of the table that explains. And these numbers need to add up to that. So this is the kind of stuff I mean, and I would think that would be table stakes in a report. I would think that you would say, well, okay, you've got a 2.21 second problem. Here's where that 14 seconds went. You should go, stop, whoa, 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 where'd the 14 come from? And then I could go, oh, well, you can ignore this 12. No, it's code path in your brain that should have been in the tool. So that's the thing that I wanted to get off my chest. By the way, if you do it right, then lots of things you don't even really think about. Right? I never really thought that much about, well, the mean of the calls that make up this 2.21 seconds should be the mean on the bottom line here. And sure enough, it is. If it weren't, it would be a bug. It would be a bug in the code that I wrote to create these two reports. So numbers need to foot. Drill downs need to have the bottom line of the top line that you drilled into, and averages that are reported up here need to be the same as averages down there. It's just stuff that you should expect, I think. So I wanted to say that. And that's part of what got me riled up at 2 o'clock this morning. I thought, I need to say this, but I don't want to, I'm always fearful of being controversial, etc. So anyway, there you go. Now, what I really want to talk about, and I didn't figure this out until 2 o'clock this morning either, I want to talk to you about the magic of interposing. Anybody here have a clear picture in their head pop up when you see the word interposing? Like, there are not any hands sticking up right now. This is awesome. This is awesome, because this is going to be a complete shock to you. I tweeted.
It's an English word, right?
It is an English word, yes.
All right.
Yes. That explains, yeah.
Yeah.
Oh.
Well, since it's an English word, I'll put my hand.
Okay. Excellent. Excellent. It turns out to mean the thing that Carrie Osborne talked about yesterday. Did you see what Carrie Osborne talked about yesterday? And Martin Kier referenced it a moment ago when he put up, there was a slide that Martin put up that is a photo of a slide, not a slide, a live demo that Carrie Osborne did yesterday that clearly is a SQL Plus prompt, and clearly it says, select 2 from dual. And it said, oh yeah, 22, here you go. Is that disturbing at all? Is that horrifying? It's disturbing. It's deeply disturbing. So Carrie talked yesterday about how to make the database run your SQL anytime it sees this SQL. That's actually a form of interposing. So let's talk about interposing in the context of a real life problem. Back in 2001, 2, 3, in that era, I was just as upset about this, these measurement tool deficiencies that I ranted about to open the talk. I was just as upset back then as I seemed when I was talking about it. And in fact, I was way more upset because I saw a market opportunity if we could fix these things, if we could make the world so people didn't have to tolerate this number and that number don't match, but a magician can explain why, and you might be able to remember the explanation for 6 or 7 minutes before it sort of starts to fade, and some other number comes in that's also weird, and you're like, oh god, now I have a triangle of these, and the code path of your brain thing. So 2000, 2001, 2002, 2003, Jeff Holt, my colleague, tasked ourselves with trying to create a process that was deterministic, repeatable, for measuring and diagnosing Oracle performance problems. And we hit upon that trace data was the way to go. And we learned this through enormous struggles trying to work with the $V and $X data. And we went through just enormous struggles with how often do we poll, and when we poll and we miss data and we can sense that we've missed something, how do we fill in the void? And I wrote a lot of code in the span of a year, and Jeff did too. And we finally, at the end of that year, figured out, you know what, the trace data is so much easier to get than to do the $V, $X stuff correctly that we're just going to lay it on the line and go with the trace data. So the trace data that I'm talking about is this event 10,046 stuff, which Carrie Osborne yesterday flatteringly referred to as the Millsap trace. I just pray it were 10,042 instead of 10,046. But alas, it's 10,046. And by the way, you guys know where that comes from? Why? Probably you've heard 10,000, but there are hundreds. And if you go to your Oracle Home RDBMS MESG directory, there's a file there, as long as you're not on Windows, but you're probably not. At least if you are, you can find an actual system you can go do this on. You can find a file called auraus.msg. And there's probably Aura, other things, .msg, like auraca.msg, where it goes A at the end of some of them. And I was up really, really late. So please just try to make me, just like, pretend to giggle, and then I won't go all meta, and where I explain how late I was up and stuff, just flow through it. Okay, so auraus.msg, if you look in there, and you just, you're in VI, and you just like slash for 10,046 and go to the line that says 10,046, you'll notice that it's in a long list of stuff. And if you scroll to the top of the list, you can see the explanation. I'm not going to get this right, but I think they're called, yeah, I am going to get this right, because I'm good. I'm a professional, and I'm going to get it right. These things are called Oracle pseudo-error debugging events. Look that up. Check me on that. Pseudo error debugging events. And there's hundreds of them. And one of them says, you know, like event, I don't know, 325. That's not correct. That's just a like fabricated example. But one of them will say, Oracle event 100 this, that. Pretend that a control file has been corrupted. Right? You don't hear a bunch of people at conferences talking about, oh, I found a way you can pretend your control files are corrupted. But at Oracle, they have to test code paths of what happens when control files are corrupted. What happens if somebody accidentally kicks the plug out of the disk drive on the redo log disk drive? Right? So instead of actually physically doing that, that would be very difficult to test in an automated way. You'd have to hire somebody, you know, to like hold their hand on the plug and you go, okay, we've finished test 47, test 48, test 40, okay, now! And pull the plug, right? You wouldn't want to test your software that way. So there's code in the database kernel code path that allows you to say, pretend that my redo log files have just gone crazy. And let's see if we can do a recovery, right? So there are all these things, and 10,046 is just one of those. And it happens to turn on what back in Oracle 6 used to be called SQL tracing. So SQL tracing was simply, it should have been really called database call tracing, honestly, because that's what the trace file contains. So inside the trace file, you'll see the text of the SQL that's being manipulated, and then you'll see things like parse and exec and fetch, which is an indication that a database call called that has completed, and you'll get data about that call that looks like this. And I think this is a 12C or 11204 or some kind of relatively modern trace data. And you see the name of the call right at the beginning of the line. So it's, this word is going to be things like parse, fetch, exec, those kinds of things. The long number here is a cursor slot ID. And the numbers used to be single digits, 1, 2, 3, 4, 5, like that, and they got long in 11202, I think. These end up being like addresses in the shared pool or something. The C statistic, which I've emboldened here, is the number of microseconds of CPU time that this thing is consumed. And it turns out to be accurate to within plus or minus 10,000 microseconds. Now, Carrie, how do you know? What page of the Oracle documentation did you find that out on? And the answer is, we don't use Oracle documentation to find out things like that, because we just don't. First off, the Oracle documentation probably doesn't tell you a lot about how to read trace files in the first place. Okay, I'll continue a little bit. The E value is the number of microseconds that this call consumed, and that value is accurate to within plus or minus 1 microsecond. So this thing has a precision of 1 microsecond, this thing has a precision of 10,000 microseconds. And this becomes important as you go through life trying to figure out why these numbers don't add up to that number. Well, this has some fur around it, some fuzz. P is the number of blocks obtained through OS read calls, not the number of physical reads. That's what P kind of is reminiscent of. But anyway, every one of these has a similar description. And what I want to describe today is how do we know so much about C? And I just told you, we didn't look it up. We figured it out. So I want to talk a little bit about how we figured it out, and this interposing thing becomes important as I do that. Now, a little bit of background. It really helps in order to do the kinds of things that my group and I do for a living. It really helps to have a computer science background, not an IT or an IS, you know, I wrote COBOL in school, so therefore, I'm talking about like, I wrote operating systems in school, so therefore. So the picture that's relevant for the next few minutes of the presentation is this one, and it's a simplification of what the states a process can take on are inside of an operating system. So this is from a book written by a guy named Maurice Bach, who was an AT&T guy that worked on the original System 5 Unix kernel. So this, again, there's like 20 of these, and I'm only showing you 4 of these states. So a circle represents a state. If you've never seen one of these before, this is called a deterministic finite automaton, a DFA. It's a state machine. So basically, there's code inside the kernel that knows what mode you're in, or knows what state you're in, and this picture represents 4 of those states that a process can be in. So I'm going to walk you through this just a little bit to lend a little bit of comfort in case you've never seen or thought about this kind of stuff before. So let's imagine you write a program to calculate pi. Right? You've got some code that does numerical analysis stuff, and it's like some Monte Carlo simulation or some kind of algorithm that you've chosen, and you've written a program to actually compute the value of pi. And at the end of this program, you're actually going to write the results out onto a terminal. So that's a little program that we can walk through, and I can show you how it behaves in the state machine. So when you're